everyone, and welcome back to our channel. Today, we're diving deep into the world of linear algebra and tackling a concept that might seem intimidating at first. But trust me, it's super useful. What is it? It is RREF, also known as Reduced Raw Echelon Form. If you've been working with matrices and systems of linear equations, you've probably heard about row operations. But take note that RREF operations is to the next level, giving us a standardized and also simplified way to represent a matrices. So, what exactly is RREF? Well, its matrix then satisfies these four conditions. First, all rows consisting entirely of zeros are antiborrowed. Second, the leading entry of each non-zero row is 1. We call this a leading one or pivot. Third, each leading one is to the right of the leading one in the row above it. And fourth, in any column containing a leading one, all other entries are 0. And now, let's break down each of these rules. First, if you have any rows that are all zeros, they've got to be at the very bottom of the matrix, like this one. For the second, every row that is not all zeros starts with 1, and that one is the first non-zero entry in that row. Look at this. Third, as you move down the rows, those leading ones shift to the right, creating a sort of staircase pattern. And finally, if a column 1 has a leading 1, everything else in that column has to be 0. Overall, this is the example of reduced raw echelon form. And now, how do we actually get the matrix into RREF? We use row operations. Remember, we're allowed to swap rows, multiply a row by non-zero constant, and add a multiple of one row to another. Okay, and now let's begin. Today I'm going to walk you through a solving of system of equations using matrix row reduction, also called Gaussian elimination. So let's say we have this matrix. We have the first row, 2, 4, and 10. For the second row, we have 1, 1, and 3. I repeat, we begin with the matrix of 2, 4, and 10. And for the second row, we have 1, 1, and 3. Our goal is to reduce this to a simpler form where we can read the solution directly. For this step 1, we do swap rows. As you can see here, to get a leading one in the top left corner, we will swap row 1 and row 2. Then after swapping the matrix, it becomes, for the first row, we have 1, 1, and 3. And for the second row, we will have 2, 4, and 10. For step 2, eliminate the 2 below the leading 1. We will subtract 2 times row 1 from row 2. We will have 2 minus 2 times 1 equals 0. We will have 4 minus 2 times 1 equals 2. And for the last part, we have 10 minus 2 times 3 equals 4. And this is the new matrix. For the first row, we will have 1, 1, and 3. And for the second row, we will have 0, 2, and 4. And now for step 3, we will make the 2 into 1. We divide row 2 by 2. 0 divided by 2 equals 0. 2 divided by 2 equals 1. And 4 divided by 2 equals 2. And now we will have a new matrix. This one. The first row, we will have 1, 1, and 3. For the second row, we will have 0, 1, and 2. And for the last one, step 4, eliminate the one above the pivot. We will do subtract row 2 from row 1. We will have 1 minus 0 equals 1. 1 minus 1 equals 0. And 3 minus 2 equals 1. And this is our new matrix. For the first row, we will have 1, 0, and 1. And for the second row, we will have 0, 1, and 2. And finally, this final matrix tell us directly that this x equals 1 and y equals 2. And that's it. We use basic row operations to reduce the matrix and solve the system. Thanks for following along. And then, there we have it. That's the RREF of our original matrix. But before that, we need to call my partner in this channel to answer some details about RREF. Hi friend! Good morning! Welcome to our channel!
Good morning.
How are you, friend?
I'm fine.
Yes, that's good to know. We have some questions about RREF, and I know that you can answer this question. The question is about RREF and why it is important.
So why is REF important? Well, it makes solving system of linear equation much easier. It also helps us to find the inverse of a matrix, determine the rank of a matrix, and understand the solution space of a linear system. Like this one, by converting the augmented matrix of a system of equation into RREF, we can directly read off the solution. Such a powerful tool, right? So, to recap, RRAF is a standardized form for matrices that simplifies many algebra tasks. It involves leading ones, zero rows at the bottom, and a staircase pattern. And we can get there using row operations. That's it, partner. I hope I was able to answer all your questions. Thank you.
Leave a comment if you have any questions, and don't forget to check out the links in the description for more resources. If you found this video helpful, please like, share, and subscribe for more linear algebra lessons. Thank you for watching!